Hello everyone, welcome to Scalers YouTube channel. My name is Aditya, currently working as a data architect at PepsiCo. Today we are going to talk about differences between a database, data warehouse, data lake and data lakehouse. This video is intended for those folks who want to start their career in data engineering, data science, AI and ML engineering. Before we deep dive into today's class, you can check out the master classes taken by the leading industry experts on Scalers event page. The link is in the below description. For similar content in future, you can subscribe to Scalers YouTube channel. Let's get started with today's class. So let's get started with core differences between database, data warehouse, data lake and data lakehouse. Let me go to the slide 1 and explain what is a database. If you can see, a database is an organized collection of structured information or a data. So there's major difference between a data and information. Anything which has a value out of it is called as a data. Information is something which you're storing which doesn't have any value, but data is something which has a value inside it. So when people talk about data, it's nothing but an information which has certain use cases or certain value points which can be derived. So database is nothing but a machine or a system which stores structured information, and typically it is stored electronically or in electronic format. All this information is stored in a computer system, and that system itself we call it as a database. So database usually is called as DBMS or database management system. Together the data along with the DBMS and all its associated applications is called as database system. A short form we call it as a database. In 2001, many transactional systems came into place. So the machines or system which is used to store transactional data, or basically data with respect to small transactions, we used to call them as OLTP or a database. OLTP stands for Online Transactional Processing System. So whenever people exchange or interchange database with OLTP, it's one and the same. So on the screen, you can see different databases which we use currently. These are the different vendors which you can see. Microsoft has Microsoft SQL Server. We have MariaDB, MySQL. PostgreSQL, again, it is a Sybase database, MongoDB, and many more. All these databases, whatever we have right now, they are classified into different types, and we are going to cover them in our next slide. So the first easiest concept is called as relational database. You can see on the screen, relational database came into practice since 1980s. Here the data is stored in an organized structured format in the format of a table, as in columns and rows. Also, relational database technology provides the most efficient and easiest way to access the structured information. So in an interview, if anyone asks you what is a SQL or what is a structured database, or basically what is a relational database? Relational database means what? Any data which has a relationship between them. For example, there is a customer data, there is an order data. So whenever a customer goes inside a shop and places an order, that order is tied to a particular customer on a customer ID. So you're able to tag or you're able to relate the order with a particular customer. So when that order was placed, who went and bought this part or that particular product can be related, can be relational, right? So that's how we call it as a relational database. Then came to practice NoSQL database. So what does NoSQL means? NoSQL stands for not only structured query language databases. So No stands for not only structured databases. You also can call it as a non-relational database, and this usually is basically used when you need to store structured or unstructured or semi-structured data. Mainly it came into practice to store unstructured and semi-structured data. So my relational database cannot evolve the schema dynamically. I already need to define the schema when I have to store data into a table, right? For example, I have a small table of 4 columns: customer ID, order ID, customer name, order name. I need to define the schema before I put the data inside the table. But my NoSQL database is dynamic in nature. So NoSQL database is basically a database which can store non-relational type of data. Basically, if a data is evolving, or basically the number of columns are not fixed, for that we have to go for a NoSQL database. but there's a relationship between my data. I can choose relational database. In case of NoSQL database, I can store dynamic data. For example, the table schema currently has 4 columns. Tomorrow it might be 6 columns or 15 plus column or 20 columns, right? The data size or the column size of the table is keep on evolving. So for that kind of data, we can use NoSQL database. In the slide, you can see NoSQL database grew popular as the web applications became more complex and became more common. So previously, uh, you remember, right, when people used to walk into any government office, they used to see those kind of registers where they need to capture data for a particular employee, for a particular student. Even when I was studying in school, uh, they used to maintain those registers. Who is the student who paid the fees on time? So they had all those registers, right? I'm talking about 90s, start of 2000. Later on, when relational database came into picture, all this data we used to store in computer system, right? That is nothing but a DB, a student DB. Basically, we are storing all the relational data of a student or different students studying in that school or a particular class. So one class will have, let's say, 4-5 sections. There are like 500 students studying in a class, let's say class 10. 500 students are studying in 4 different classes. And who is the teacher with each subject, how much marks they are getting scored in each subjects, and if they are paying the fees on time, what is the rank of a student. All these things are, stored in a database. So currently all this information is stored in different databases, right? That's why we call it as a relational database. Now let's talk about distributed database. I hope you know when to use a relational database and when not to use a relational database, basically when to use a NoSQL database. Now let's talk about distributed databases. If my data volume is so huge that I cannot store it in a single database, right? I need to store it in different database so that we can process the data parallelly and process it so in such an efficient format that my processing time is less and my efficiency is more. So that in that case or that scenario, we have to go for a distributed database. So as you can see, a distributed database consists of 2 or more files which are located at different sites. The database may be stored on multiple computers located in the same physical location, or it can be scattered over different networks. So if you take an example of ISRO database, for example, the database is not stored in single location, which is in Chennai, right? I might have one database in Bangalore, I might have one database in Chennai, one in New Delhi and one in Hyderabad. Why I'm storing data in different data centers or databases is because if suppose this database is down, tomorrow I might need to recover it, or I need to, get it from some other point so that my system doesn't stop functioning. So that's why I distribute my data across different databases, which is located around geographical locations, right? So that's where I used a distributed database. Now we have another category of database, which we call it as object-oriented databases. This is, to store the data in much more compressed format, in the format of an objects. Similarly, like how we do our coding or programming, we store the data in the format of objects. Basically, you can use the coding functions to store the data in form of objects. Now let's deep dive into what is a data warehouse. So data warehouse is again a DBMS system. It is used to store intelligence data, basically business intelligence data. Uh, Data warehouse can store history data. So there is 2 types of data. One is OLTP data and one is OLAP data. OLTP is nothing but online transactional processing data, basically a database data. OLAP is online analytical processing data, basically any data on which you need to perform analysis. That data cannot be stored in OLTP or a database because it's a huge data. It's a like last 6 months or last 1 year or last 2 years of data. You cannot store it in a database. If you store that data in a database, your processing time of database will go down. The database is designed to work fast and process the data quickly. But if I want to do analysis on a data warehouse, so I need to maintain huge set of data. And data warehouse is designed such a format that I can maintain last 6 months or last 1 year of data and pull all this data together in one particular system from where I can pull it to different, areas. It can be called as visualization area, reporting area, or any other purpose. So data warehouse is nothing but capturing the data from different data sources. Let's say data source 1, 2, and 3 you're trying to pull the data from different data source. You provide a function, or you provide a concept of ETL, basically extract the data first, transform it, and then load it in a data warehouse. So when you're extracting it, you make sure you transform it as per the business logic or as per the requirement, and then you load it in a data warehouse. Data warehouse is a huge repository which stores huge amount of data, which can be used for visualization purpose. Basically, you're preparing a kind of a graph or a tabular pictorial representation of a graph for directors, senior VPs or VPs, which they can showcase the kind of data derivatives in the format of a chart. You can use data warehouse to prepare reports. You can prepare Power BI report, Tableau reports, and for example, all these job roles is mainly covered as part of business intelligence. So database is used to store small data. Data warehouse is used to store large data. Database is not for analysis purpose. It is only used to store transactional data. Data warehouse is combination of the data from all the different data sources. Again, it depends upon the business use case, how much time of data you can retrieve, let's say last 6 months of data or last 1 year of data, and you can perform analysis on top of this data. You can give it to a business intelligence guy who can prepare charts or different reports by using history data. I hope I have covered all the information with respect to data warehousing and OLAP. Now we'll explain the next topic, which is data lake. And this concept usually came into practice when big data or data engineering came into picture. This was around 2001 when Google came up with a concept called Google File System, GFS. GFS is a concept of HDFS, Hadoop Distributed File System. Apache was the first company and Yahoo was the first company to implement Google File System to come up with the concept of HDFS. I'm going to discuss data lake and we are going to cover this in depth. So now let's understand what is a data lake. Before we jump into the concept in depth, I wanted to show you the difference between database, data warehouse, pictorial in the pictorial representation, and then I'll also show how the data moved ahead to a data lake. So this is my database. It is used to store OLTP data, basically anything which is called as a transactional data, right? So all the data when you are doing a transaction, let's say you went to a shop, you see the messages, what you receive on your mobile phone, it's so fast, right? Within seconds or milliseconds, the amount of money which is deducted from your account, the same amount went to a merchant in their account, right? So the messaging is so fast that the entire processing is very fast. So that's why you use a database, which we call it as a DB, right? But if the companies want to analyze this data, they have to go something towards a bigger database, which we call it as a data warehouse, right? So you can call it as a data warehouse. But the problem with data warehouse is it can only store structured data, basically any data within the format of a structured tables, right? It can store inside data warehouse, and that's why BI usually consumes structured data directly. If I want to derive a business intelligence report from an unstructured data, I need to use some other concept. So that's where data lake came into the practice. I think around 2001, we were seeing a lot of new devices like IoT devices, sensors. There were different new machines which were coming in the market, which were consuming or producing unstructured data or semi-structured data. There were other applications like Facebook, LinkedIn, YouTube, which were giving us different kind of data, right? To process all this kind of data, I cannot derive output or insights from a data warehouse, obviously, because these are unstructured or semi-structured data, right? So engineers thought of a concept. What if I'm getting unstructured or semi-structured data? How do I derive insights out of it? Obviously, you cannot use data warehouse to store them because data warehouse is only designed to store structured data. So since different applications right now are working on semi-structured or unstructured data, I need to have a system to store that kind of data first of all, and then parallelly process it. So to process, obviously, we had big data systems to process big data format of a data. But how do we store that? That was a major, major issue with many of the systems. So there was a concept called as a data lake. Data lake is nothing but a kind of a lake, I can say. It is used to store structured, semi-structured, unstructured data, right? Unstructured data. But why I need to use a data lake? And what is the major advantages of using a data lake? So data lake is used to store structured, semi-structured, and unstructured data. But if you ask me a question, why do I need to use a data lake? Because data lake is very cost effective. It is very economical, and you can store different kinds of data. So this entire system where you're storing all this kind of data is called as a data lake. And to understand the major outcomes of using a data lake is, I can derive Power BI reports or basically any reports out of structured data. I can build any BI reports out of structured data. And to process semi-structured or unstructured data, basically these are the data which is used by data scientist team for AI or machine learning to build up their models. I can still connect to data lake, right? So data lake gives me flexibility to use semi-structured data, unstructured data, and structured data, right? So this part of data is basically used by data scientist team to do advanced analytics, right? But the structured data is used by business intelligence team to get Power BI reports or any other reports which is required by the company leadership team. So that's where data lake came into practice. It can help us to store different kinds of data at a very cheap price. Data warehouse is very costly when compared to data lake, but data lake, the price of data lake is peanuts basically. So in a data lake, I think in one data lake storage, you can store up to 5 TB of data. So this is what I wanted to speak about data lake, and you can see into the screen PPT. Data lake is a centralized repository, as we have mentioned, that allows you to store all the structured, unstructured, and semi-structured data at any scale. You can store your data as is, right, without having to structure it first. Yeah, this is one more important concept which I wanted to discuss. In my data warehouse, before I store any data, I have to make sure like I need to transform it or I need to basically change it as per the business requirement. But in a data lake, I need not transform it because there's a concept called as ELT, extract, load, and transform. So basically extract all the data from data sources and directly load it as is in a data lake. Now, depending upon the business, how much data they want to, study or how much data they want to analyze, that amount of data they can only transform. So data lake directly pull the data from different data source, store it somewhere without doing any transformation. That repository entirely is called as a data lake. So we have shown that in the data lake diagram, and data warehouse, these are all structured data and transformed data. So I can use two concepts. One is ETL, other one is ELT. ELT is basically used whenever data lake is required, extract all the data, load it in a data lake. But ETL, majorly it was used before, I think 2000. We are extracting the data, transforming it and loading in data warehouse. So that's where we have covered the concept of a data lake. Basically extract the data, load it, and now depending upon the business use case, you can transform whatever is needed for the business requirement. Let's talk about data lakehouse. As you can see on the screen, data lakehouse is a new open management architecture that combines the flexibility, cost efficiency, and scale of data lake with data management and asset transaction of data warehouse. I know this seems a little bit difficult to understand. Let's discuss how we can break it down into simple terms and terminology. So as you can see on my screen, we initially had databases to store transactional data or data which is fast moving. Then we had a bigger database which we call it as a data warehouse, right? This is my database. This is my data warehouse. Data warehouse. Then I understood, okay, if I want to store semi-structured or unstructured data, I need to store it in a data lake. So this is my data lake, TL, right? The problem with data lake is I cannot store data which is where I can do time logging, or basically I can't go to a particular time point and retrieve that data. That is one of the challenge. Secondly, ACID compliant data. Basically, ACID stands for atomicity, consistency, isolation, and durability. So if I want ACID compliance data, I cannot store it or retrieve it from a data lake. I have to go to something called as a lakehouse, data lakehouse. How this term came into picture. First, we'll get into that, and then I'll explain the advantages of it, why it came into picture. So lakehouse, we have data lake plus data warehouse. So I will take lake, I will take warehouse. This will give me lakehouse, right? So lakehouse is a place which is used to store data. So this is called as data lakehouse. So take data lake and add it with warehouse, you get data lakehouse, right? So we are not just adding the terms, we are also adding the functionalities of it. So data lake gives me optimal storage at a very cheap cost, right? Data warehouse gives me ACID compliance, basically compliance of ACID rules. It also gives me to access time variant data. I can basically go to any point of time and pull data for that particular year or period. That is also one of the flexibility given by data warehouse. So if I want to combine both the things together, I can use data lakehouse, right? And one more thing is basically uh, why company cannot directly use data lake. Previously, from 2015 to 2020, people were using data lake. They understood one problem. The problem is when you're storing huge amount of data in data lake, after some time, it creates something called as a data swamp. Now you will ask me, hey, what is data swamp? Data swamp is something like when you're storing huge amount of data, after a certain time, you won't understand, okay, this data belongs to me or this data belongs to someone else. Basically, it's a mixture of entire data. So again, to rule out which data belongs to whom, we need to have a proper system called as cataloging, or basically differentiating the data. It belongs to which stakeholder, which company, or which subset of area, right? To use or to derive that kind of input, you need to go for a data lakehouse. So that's where advantages of data lakehouse is you can store any scale of data. Basically, it's a outcome of a data lake. You have ACID compliance coming from data warehouse. You can access time variant data. Again, it's a concept of data warehouse. And there is no data swamp. Basically, you can catalog. There is no data swamp. You can catalog the data, or you can go to any part of data which you want to figure out. So these are the difference between a database, data warehouse, data lake, and data lakehouse. So this diagram, whatever you see on the screen, I have explained you in the same fashion. You can see a data warehouse is used to derive BI and reports. Data warehouse captures all the data which is coming from different DBMS or different databases. You use extract, transform, and load because you extract the data, transform it, and the final transform data, you're loading it in data warehouse. Data lake, you need not transfer anything, directly extract and load it as is, right? Data lake can store structured, semi-structured, and unstructured data. And there are different use cases as we have discussed. The structured data is required for BI and reports. The unstructured data is for data science and machine learning, right? And Lakehouse, it's a combination of different functionalities of a data warehouse and data lake. You can do all your processing, create reports, data science, machine learning. Major advantages is ACID compliance is maintained. There is no data swamp. You can fetch the data very fast by using data warehousing, data cataloging, and you can also figure out and fetch the time variant data, right? This is what we have discussed. Always remember, data lakehouse has the combination of the functionality of a data lake and a data warehouse. Now let's understand the advantages of using the lakehouse architecture. As I discussed on my diagram as well, metadata layers for data lakes. So what is metadata layers of a data lake? It basically means you have different layer on top of data. Basically, you can pick up or go to a particular layer which points out to my data. For example, let's say I have 5 TB of data. I want to figure out, okay, where is this particular customer located at which region he is located. So I need not process the entire 5 TB of data, right? I will be having different location data stored it in different catalogs or different layers. I need to process only that particular layer. I need not process the entire 5 TB of data. So I have different metadatas being prepared. Metadata is nothing but a skeleton structure of the data. For example, if I want to store students data, right? My student data will have a metadata of student ID, student age, student name, which class or which school he's studying, right? So depending upon the better metadata, I will only scan the metadata and figure out, okay, if the metadata has the proper column, only then I need to scan that particular metadata or the table. So metadata layers on top of data lake was enabled on a Lakehouse, which helps me to query my data very quickly. So second point which I'm going to cover is the new engine gives me a very high performance on SQL execution because we have metadata layers. And obviously, since query engine performance is fast, we have optimized data access for machine learning and data science models. So that's where a company realized like data lake was not giving that fast performance of querying engine, whereas data lakehouse has improvised the performance when I need to fetch the data quickly. So all my AI models, all my machine learning models depends upon how fast I'm able to process the data. For example, if you're buying a product on Amazon, let's say you're buying a watch, Amazon will give you a prompt recommendation. Hey, you're buying a watch. Why not you buy some equipment which you can carry with your watch? For example, uh, mobile application. You can buy a mobile app or you can buy something which is paid, right? Along with that watch. So that recommendation is so fast, how that recommendation is working because on the back end, my AI models are running, which is querying the data from a data lakehouse. So that's where, data lakehouse came into picture, which is using the fast, which is using and working on the fast querying engine of a data lakehouse, also which is retrieving data from a particular metadata layer. I hope you have understood this concept. If you enjoyed watching this video, please do like and subscribe to Scalar's YouTube channel. Thank you. See you again.